Hello everyone. In this video, we will introduce the force of mortality. Let's get the relationship between the density function and the distribution function for the random variable Tx. The density function for Tx is the derivative of the distribution function big Fx of t with respect to t. In terms of the survival function, this equals the negative of ds dt. In terms of the actuarial notation, the density function equals dtqx dt, or the negative of dtpx dt. To get the distribution function or the survival function, we simply use integration to integrate the density function. That is, the distribution function fx of t is the integral from 0 to t of the density function. And then the survival function equals 1 minus tqx. This is the integral of the density function evaluated from t to infinity. Or if we have a survival model with an upper h limit, then the upper integral limit becomes omega minus x. This is the maximum future lifetime for an individual at age x. All right, so we get the relationship between the density function, the distribution function, and the survival function for Tx. Now we get to the force of mortality. The notation for the force of mortality at age x denoted mu sub x. The force of mortality is greater than or equals to 0 for all x, and this measures the instantaneous rate of mortality at age x. And this is the definition for the force of mortality. This can also be regarded as the probability of death within a short period of time when the individual already survived to age x. All right, now we express the definition here in terms of S0, the survival function of a newborn. So this expression can be rewritten as S0x minus S0x plus dx over S0x. This is for the probability statement, and then over dx. Upon simplification, mu x equals the negative of ds0 dx over S0. So we get the relationship between the survival function for a newborn and mu x, the force of mortality at age x. The expression here can be rewritten as the negative of d, the lateral log of S0 with respect to x. All right, we get two expressions, and then we will further extend these two expressions to develop more relationships. All right, the first one, take the fact that the density function for Tx equals the derivative of the distribution function or the negative derivative of the survival function. Here, this can be rewritten as F0 over S0. And we can get the density function of a newborn F0 equals S0 of x times mu x. In terms of actuarial notation, S0x is simply xp0. And then for the second expression, we would like to develop a formula for finding xp0 given the force of mortality. Take the integration on both sides, and then we further simplify the right-hand side. The right-hand side can be evaluated as the negative of the lateral log of S0x plus the lateral log of S0 at 0. From the properties of a survival function, S0 at 0 is 1. So the lateral log of 1 is 0. So the right-hand side only have the term the negative of lateral log of S0 of x. and this is the negative of the lateral of xp0. Solving for xp0, we get the expression. Given the force of mortality mu x, and then we can get xp0, the survival probability of a newborn reaching age x. All right, so we have all these relationships, and then we will apply these relationships in terms of two examples. The first one, given the force of mortality, we would like to find the survival function of a newborn and then the corresponding probabilities. And in the second example, we have the survival function, and then we are asked to find an expression for the force of mortality mu x. All right, the first example, given that mu x equals 1 over 1 plus x, and then we would like to find S0 of x, 10Q15, and the expression for TPX. All right, so part A, S0 of x, which is xp0, and we get this relationship. So we simply take the integration of the force of mortality evaluated from 0 to x, and then take the negative of this expression and then do exponentiation. Upon computation, we get S0 equals 1 over 1 plus x. And then part B, 10Q15. A person at age 15 will die within 10 years. This equals 1 minus 10p15. We already obtained an expression for S0 of x, so we can express 10p15 as S0 of 25 over S0 of 15. Substitute x equals 25 and x equals 15 respectively. Upon computation, we get the probability 0.3846. And then part C, the expression for TPX. This equals S0 at x plus t over S0 of x. The expression for S0x is 1 over 1 plus x. So S0 of x plus t is simply 1 over 1 plus x plus t. Upon simplification, we get an expression for TPX, which is 1 plus x over 1 plus x plus t. All right, the second example. Given the survival function 1 minus x squared over 100, find an expression for mu x. We can get mu x in two ways. Since S0 here is a polynomial, so we simply use the first expression here. Directly take the derivative of S0 with respect to x. So take the derivative of 1 minus x squared over 100 with respect to x. Then we get this expression, minus 2x over 100. And then upon simplification, we get the force of mortality, 2x over 100 minus x squared. All right, that's it for today's video. In the next video, we will continue the force of mortality.